Hello, doing pretty good.
Yeah, so more tricky question. Where are you today?
Basically at home.
Okay, great. Guys, let's start because there's no reason to waste the time. Especially we need to switch, at least some of you need to switch to the traditional classes at the university soon. Okay, let me share my screen. My name is Michał Kucharzak, and that's my pleasure to conduct the computer networks course with you. Unfortunately, we are now in different faculties, so we are representing different faculties, and I don't know how this subject may look in future. So taking into consideration that it would be easier to pass still this year, I would say. Okay, we are still continuing this pandemic version. That's why we are now having this remote stuff. And before delving into details, before jumping into organizational stuff and the course introduction, let's check some warm-up quiz. So now I need your at least the small engagement just to speed up with this topic. The question is, what is it in the picture?
It's router.
Yeah, we can say so for the sake of simplicity. What is it?
IP address.
And being more specifically?
For IP4.
IPv4, yeah, version 4 of IP addressing. Okay, this one, this guy. What it is?
Network card?
Yeah, that's network card or yeah, network interface card to be more technical. Here, this one, I can bet you know.
Ethernet cable.
Yeah, some cables, wires in for the network connection. And what is it? Yeah, this is wireless stuff actually. Okay, let's go through to the course information. So yeah, my name is Michał Kucharzak, as I already said. You can, or my room is 235 in C4. There are no office hours defined yet because we can have some slide updates in our schedules. So I will announce as soon as possible. Normally, you can try to catch me via MS Teams or via mail. That would be the most efficient way. However, I have several classes, several labs, also including Polish divisions, so that we can meet face to face if needed. Okay, we have one semester for this lecture. We will meet every week. At the same time, we will have online classes. So the actual, let's say, plans are or have been modified already. We'll have also online exam regarding the lecture here. So the room planned for this lecture is already, let's say, I would say, deassembled. So it is now only online classes for the lecture. However, for the laboratory, we'll have traditional meetings with, let's say, in-house, let's say, meetings, and there are 3 slots for that. You are already there. So yesterday I met parts of your group, and today we will continue with the rest of your specialization. The goal is that I'm not sure if this is the final shape of the laboratories. I mean the slots. I know the rules are that we need at least 10 students joining the course, and on this today 5 to 7 we have only 8 people enrolled there, but we will see how we'll end up here. So take that into consideration that we can have, or you can have, some small changes in your schedules. Okay, what's the real need for computer networking? So I would simply illustrate that in a few ways. So without computer networking, we have, let's say, this situation. Thanks to computer networking, we have this situation. But normally, the best argument for computer networking and why it is really needed, why we really need computer networks, is that networks are cool. So we will also discuss more details and more, let's say, we'll have more talks regarding the need for computer networking during the labs. So don't worry if those arguments are not really valid for you. Yeah, but guys, the networks are really cool. And what I'm always highlighting is that computer networking has a huge theory inside. But fortunately, this theory is easily mapped, or can be easily mapped, to the practice that we'll also play in the laboratories. So we can combine, we can get the skills and knowledge by combining the theory that is really matching the practice. Okay, let's go through the course details. So we'll have lecture and lab. So during the lecture, we will cover some fundamentals of computer networking, some background theory, terms, acronyms, and so on. And one of the most important stuff that is baseline, a kind of baseline for computer networking, is layered model, or different layered models, and protocols related to those models. And most of the materials, or all the materials related to lecture, are available in ePortal. Actually, you should have been enrolled there, I believe. If not, we will discuss the details of accessing to the portal during the lab. So in ePortal, you can find more details that will be also discussed during the laboratories. And for lab, the content for the lab is covering the basics in routing and switching. And routing and switching are two different, let's say, aspects and two different areas here. And those are also technical terms, routing and switching. We will design and configure the computer networks. We will play with IP addressing, including IPv4 and IPv6. We will cover the Cisco course that is entitled Introduction to Networks. And the materials for the laboratories are accessible via ePortal and via NetACAD. NetACAD is the Cisco proprietary, let's say, platform. And you should have the access there, and you should have the invitation link in your students' mailboxes. But this is something what we cover during the laboratories, just a heads up. Regarding the objectives, the subject objectives are already defined in the subject, this card of the subject, the definition of the subject, but more or less the goal of the classes here is to gain basic knowledge in the field of computer networking. Especially this is course related so much in computer networking. Have you had some, or did you have some, I don't know, introduction to telecommunication or something like that would cover partially the communication topics or computer network topics? So even though if you are not sure, we will cover basics in computer networking here, including some applications and the role of the computer networks in the modern world. Another objective is to gain practical knowledge and skills regarding computer networking. So it will be construction, building, designing, configuration, IP addressing, and so on, analyzing the network traffic. We'll also gain some social competences, including the understanding behind the certification and standardization in the field of computer networks. Regarding educational effects, we have three related to knowledge. So it is after passing the course, you will be able to explain and describe the basic information and the basic theory behind computer networking, the standards and technologies and protocols or cables standards related to computer networking, and also basic information related to designing the computer networks and designing and configuration. Regarding the skills and practical stuff, you will be able to construct or to build and configure some simple computer networks, including basic network devices like routers, like switches, like end devices, and so on, including designing of IP addressing schemes and using diagnostic tools. Another, or the second educational effect, is the skills in using of network protocol analyzer. It's another, let's say, software that is very usable and widely used also in the companies. It's not only for the purposes of the laboratories or this course, but we'll cover some tools and techniques that are really, let's say, living in the companies and in the modern IT areas. So we will also be able to configure and manage popular network services. And we have only one semester for that. Okay, regarding competence, we will have the better understanding of the idea for normalization and certification and standardization in the computer networking. This is just rough plan for the lectures. So today we have organizational information, this course introduction, and we also cover some introduction to computer networks. There is no the time is really short, so I'd like to speed up with some stuff. So then we also covered protocols and layers, the other layered model that is called TCP/IP. We will cover then all the layers, including IP addressing, Ethernet and switching, Internet protocol that is IP, actually subnetting and routing. So it is kind of calculations based on the Internet protocol rules. Transport layer, application layer, physical layer, those are the very important layers that are, let's say, being defined by the standards in computer networking. We'll talk about virtual LANs and some security stuff that is related to computer networks. For a laboratory, we will follow mainly the Cisco, let's say, course and Cisco materials. And there are 17 modules covering different topics. So we will play with some theory provided by Cisco. We will play with practical exercises and experiments in the lab with real equipment. We will have also some tools and simulators that are great enablers towards gaining the skills and knowledge in this area. So what I'm also, again, highlighting is that this basics of computer networks is the knowledge here is kind of free of charge, I would say. And there are plenty of materials, links, vlogs, blogs, and some tutorials in the internet already that are covering most of the topics we'll cover. So feel free to, to grab any source of information that could support you in understanding the materials we will cover here. What I'm, let's say, promoting is learn by practicing here, and we'll play with Packet Tracer, and it is a tool by Cisco. It is free of charge for the audience here, for the participants of the course. So we'll install that. You can install that in your private stuff while getting access to the NetAcad. This is Networking Academy by Cisco. For lab, and you can learn here very, very many things related to configuration, to theory, to protocols. You can do some diagnostic. You can learn all this stuff we will cover here. And also it is required by Cisco because we'll have some exams related to usage of this tool. Another free and open source tool is Wireshark. This is a packet sniffer or packet analyzer that is also used by engineers around the world, not only the students in this course, but it is a tool used widely in the world, not only in the networking, but also in some other IT stuff that we'll also cover during our classes. So yeah, access to the ePortal, there is the computer networks. You should be there already, assigned automatically, as far as I know. If not, we'll continue the getting the access during the labs. And NetACAT, I already announced that, so you can check your boxes and check if you have the access to the NetACAT. This is the Cisco platform, and plenty materials are there. You can download Packet Tracer. The newest version is 8.01 from the NetACAT. It will be used very often, so please do it. Find it somewhere in the resources tab or somewhere there. You can find it easily. Also, Wireshark might be downloaded from Wireshark.org. It is open source, free of charge tool. We will cover it. Okay, how about final grade? So in the lecture, we'll have some midterm tasks and assignments that might be mandatory, might be optional only. We'll have one final exam regarding the lecture and one attempt, and the second attempt is also allowed for the lecture, and the exam questions will be partially prepared by you. So the more you can understand from the computer networking world, the better questions you can design. So then the life would be easier, because I could reuse your proposals for questions in the final exam. Regarding the lab, we will follow the Cisco, let's say, schedule, and there are plenty of exams, tests, quizzes, and assignments. There is a skill exam that will be kind of hands-on exam in the lab, so we will have some limited time to configure some network. And we will have some exam, theoretical test that is also driven by Cisco. And this is on the lab. And final grade I proposed this year is 40% from lecture exam and 60% from the lab. So I'm promoting the practical approach here and learn by practicing. Regarding the literature, as I said already, I'm not listing here any books or other materials, because the Cisco, these NetACAT materials are somehow comprehensive enough. However, there are plenty of external links, YouTube videos, blogs, tutorials that will help also and will support you in gaining the skills and knowledge. So feel free to find any of those stuff. You can simply ask me if something is not clear. Okay, so the question, my favorite question at this stage, is why do you think computer networks are important? Just if you can summarize or give an example, or what's your opinion?
Probably because of computer networks, this meeting is possible.
Yeah, that's one. Yeah, funny stuff. Yeah, without computer networks, we couldn't have computer network subject. Yeah, and actually continuing this let's say way of thinking. Yeah, definitely, computer networks are important because it's easier to get ECTSs here. Okay, let's start the lecture. So I have few slides related to kind of introduction to the computer networking. So before we will jump into tough technical theory behind computer networks, let me share some really short introduction still today. Okay, so agenda of this presentation is that I will say a few words about acronyms in computer networking, about communication as the abstract or high level need of human beings, and go through beginnings of computer networking, including some historical facts and some challenges in networking, challenges for engineers, challenges for researchers, challenges for the workers and IT staff for the future. Okay, regarding acronyms, you need to be somehow familiar, or you need to be aware that there are plenty of acronyms in computer network world. That means, yeah, there are plenty. This is only an extremely short list to show you that there are plenty of different acronyms, and we will cover most of them during this semester. So don't be afraid of acronyms, and please get used to acronyms and the definitions behind it, because we have standards, protocols, we have some naming conventions, and most of this stuff is directly mapping to some crazy acronyms like IP, for example, Internet Protocol. Okay, what about communication? As I already said, the communication itself is kind of, human being need from the beginning of, let's say, this world or this universe even, and how we can define the communication. So there are, let's say, three short definitions of what communication itself is. So the communication is a process by which information is exchanged, and so on. So between the parties, different parties, through a common system of symbols, signs, or behavior. Or simply speaking, communication is an exchange of information, or communication is the imparting or exchanging, so almost the same definition, information by speaking, writing, using some other medium. So this is the abstract, high-level definition of the communication. So everywhere we have kind of exchange and information. And how to exchange the information? We need to have symbols, signs, behavior, speaking, writing, other medium. So this is the goal of the communication, and actually how we can exchange information, how we can apply communication. We could do that by running slaves, by riders, by carrier pigeons, by signals or beacons like smoke signals, fire signals, and so on. We have in the history of communication itself some semaphores. So we had some medium called semaphores. We had some signs, the meaning of the, let's say, positions of the shapes displayed via semaphores, and we exchange the information via this tool. And it was the semaphores were used 50 or 70 years ago still in, I believe in France we can make some semaphores still. They are maybe not used for communication, but as a touristic stuff. Okay, then we applied the electrical signals and copper cables to send some, again, signaling to exchange the information. So after electrical, this network by Samuel Morse and the Morse alphabet, some telephone and speech transmission was also achieved in 19th century. So it was another tool providing or enabling the communication, and communication is exchanging the information. So we can exchange information via different, let's say, methods, and electrical signals is one of them. Okay, how about beginning of computer networking itself? So we have some kind of telephone or telephony networking, and now we are going towards computer networking. So the in the very beginning, in 1957, Soviet Union launched the Sputnik and some, universe programs. So US was extremely shocked by the technical and engineering achievements of Soviet Union, and they started some organization called Advanced Research Project Agency. And this agency was responsible for multiple different topics related to defense or to military stuff. And one of the, let's say, child of this agency would be the computer network. In between, there was also standardization in coding. For example, ASCII code was defined in 1963, and ASCII code is used in computer networks also as one of the solution. Yeah, but going back to this ARPA or DARPA organization, it was responsible for doing some projects in military and defense stuff. And one of the project was focusing on building or rebuilding so-called computer networks. So before the tool that we are calling now computer networks, we had some telephone networks, and it might be illustrated as these extended, let's say, stars. So we had some centralized points and links connecting those central, let's say, hubs. And the basic idea behind computer networking was to a bit distribute this or decentralize this these central hubs, especially for military attacks. So we can imagine that if this node, if this element is destroyed, we are losing the connection in the whole network. But here, if one of the element in this graph, in this diagram, if one of the device here is destroyed, we can still have communication via the other path. So this is the underlying idea behind computer networking, and also internet nowadays works exactly the same way. Okay, there is some history. I don't want to spend too much time on that, but we started with some 4, let's say, universities, 4 nodes or 4 computers, let's say, connected together in the US. 3 years later, more and more universities were added. This is some log from the first message that was sent from one node or from one computer to other throughout the few, let's say, states in the US. Then we had some commercial investments in computer networking. So the Xerox company defines the experimental protocol. That means the protocol is the kind of a standard or the system for communication. And this is the let's say picture from the standard that we have the yellow tab here, yellow cable actually. That was defined, and actually this color, the yellow color, was also defined by the standard. So this picture is showing yellow cable. This is the copper cable, and we have some computers connected with some tabs to this. So we have the metal here and metal here. So via metals we can send some electrical signals, and that was the first experimental protocol. Then the ARPA organization experimented on satellite networks. However, all the ideas, all the technologies were based totally on different solutions. So satellite networks were totally different. Mobile radio networks were totally separated technology. This experimental Ethernet was totally a different piece of the engineering. And all the existing protocols, all the solutions were not suitable to run here, or here. So we couldn't say at this time, we couldn't say that we have computer networks. We have some cable-based network, some satellite stuff, mobile radio, but all of those technologies were separated. However, then some TCP/IP suite of protocols was proposed. In this year, we had more than 10,000 machines connected to the networks. Then the DNS, that is domain name system, was specified. Today, we are still using it. It's 40 years ago, almost 40 years ago, the system was developed, and now we are using widely. Even now during this online meeting, TCP/IP adapted those first ARPANET networks. So the network designed by ARPA organization. So okay, then this ARPA that was based on military, let's say, needs was transferred to some NSFNet for universities themselves. So for some research only. And it was still not available for commercial use. However, IBM noticed that it might be a good business or a good tool to build some networking, and more corporations, more and more private companies started investing in computer networking. It was not only, let's say, science-based tool or military-based tool, but it was seen that some commercial benefits were, let's say, visible by commercial stuff. So thanks to that, the computer networking development speed was increased. Yeah, speed was increased in this area. And few facts that World Wide Web, that is, or Amazon. So World Wide Web and web browsing is a bit older than most of you. We have Google, Skype, Facebook, and some new technologies, new protocols, new services that are based or are working and are earning money thanks to the computer networking. So we cannot escape from using computer networks today. Even with our smartphones, we are connected to the networks. And from abstract perspective, it might be seen we are connected to computer networks. Regardless, this is telecommunication, teleinformatics, or computer itself. There are no clear boundaries nowadays. Okay, how about internet forecast? Seems that there are the billions of users, of internet users only, is growing and growing every year. And also we have some other devices that are connected to the network via different technologies. For example, 5G cellular technology is also providing us with the access to the internet, to the computer network. So regardless the access technology, that is a part of computer networks only, the growth here is seen, and there are some specific, let's say, technologies that might be growing, another like 3G, UMTS, WCDMA, cellular technologies might be a bit dropping in their participation in the market shares. Okay, having said that, there are some high-level challenges in the networking, and those challenges are, as I said, kind of high-level challenges, but we need a kind of engineers, we need researchers, we need some science to be done also to cope with those challenges, to solve the problems, to solve the issues, to attack the challenges in networking too. So for example, one of the challenges is how to address unambiguously our devices. We have billions of different devices. How to provide the correct identity for them, correct identification, identifiers, correct addressing for them. So how to provide the devices are uniquely or unambiguously defined in the big network, or how to provide large scale addressing. So we have billions and billions of devices. So there are more devices connected than people living, because we can easily imagine smart homes, smart TVs, printers, and smartphones. So more and more devices. Now also there is the automotive also investing or using the car-to-car communication. It's also a kind of computer networking. All cars will have internet access. So how to address those stuff? Another is reliability. How to guarantee that all information in this communication process, and once again, communication is exchanging information. So for sure we can send a pigeon, but now we have other tools. Network. So how to guarantee the exchange of information is accomplished? What might be the algorithms to guarantee this? What might be the policy? What might be the required devices? What might be the protocols? How to design them? How to design reliable communication? This is the high-level challenge in networking. Another is security. How to provide authentication? How we make sure that the person or entity or agent is this one. We cannot see who is on the other side of the internet. How to provide the authentication? What are the mechanisms? What are the needed hardware here? What are the costs of implementing this kind of security? Another question is how to provide confidentiality here. So those are, once again, abstract questions that we need to address by the use of technologies, of protocols, and our, let's say, engineering skills. Another question is scalability. That means how we can ensure the network can grow and grow with the same set of protocols, with the same set of algorithms. It is really scalable. It is really accessible. And there are for sure some solutions, but if they are efficient, if we need more engineers to solve some problems, if we have some gaps that are not covered yet, if we have some drawbacks in the computer networks, this is the question. Of course, on top of that, there are some economical aspects, not only technical, but for example, how to charge, how to earn money for this, how to earn money for maintaining the infrastructure, how to charge for some services or for some hardware, and so on, how to apply some policies, how to apply protocols or standards. Is it possible to standardize the charging procedures? Or how to differentiate quality of service. So now in the internet, as such, is work in so-called best effort manner. So all the traffic has the same priority. But maybe the needs of the current world, the needs of the nowadays technologies may require some prioritization in sending the messages, in providing the communication, meaning exchanging the information. So how to differentiate the quality of service? Of course, there are some proposals, there are some protocols, there are some algorithms, and we will try to cover that. But this question is still open for future engineers. Another, besides technical question, we have some legal stuff that might be also connected to the computer networking. In this course, we'll cover more technical aspects. However, in the background, we can have also legal and some law-based requirements with the question how to prevent from publishing illegal contents, for example. How to prevent from using the computer networks illegally. How to harmonize the law in the internet, while internet is a global network and we have different, let's say, countries, different laws, different approaches in the legality aspects. So this is also kind of the challenge for computer networking. And we'll try in this course, we'll try to address the technical stuff mainly. We'll cover basics of computer networking, and it really requires from you the engagement, focus time, and some investing in learning and getting the skills. I think it's not really possible to pass this course only by attending it. You need to really spend some time to get some basics, but to be honest, the content is not so difficult. In many, let's say, secondary schools, some materials are already covered. So it's not kind of, quantum physics that might be not understood by everyone. However, it is kind of iterative. The knowledge here and the materials here will come in kind of iterative manner. So if you in case you lost some previous materials, it might be a bit tricky or even difficult to catch up with other stuff we will be discussing. So what I'd like you to do is really start learning or using computer networks in the engineering way from the early beginning. of this course. And thanks to that, we will have real fun during laboratories while playing with equipment, while exchanging the skills and knowledge, while troubleshooting the different situation and different aspects that we can face or meet in the labs. Okay, guys, do you have any questions? Organizational or technical?
No.
If not, I believe that's all. I will be still available for some time online, and with some of you we will see still this afternoon.
Sir, I actually have a question.
Mm-hmm. Yeah, please.
What resources or in what ways can we practice the content of computer networks?
Okay, more details I will share during labs. There is this NetACAD that is our baseline for computer networking, and there is plenty of theory. There are also exercises. We will have a simulator on which we can play the configuration of real equipment. There is a lot of tools because our computers are already connected to the networks. So there are some tools like Wireshark that we can use locally in our laptops or computers, and also learn and observe the traffic that is already generated while having these online classes. So there's really lots of material. I will also share the homeworks with some reference YouTube videos. And you still today is maybe to go to the ePortal, and there are some more details that I will share during labs, so I don't want to overlap now with all the information. So during labs we will discuss some more technical stuff, and there are some references, some materials that you can start even today learning, watching, and playing with those exercises. Especially most of you have already some switches, routers, wireless routers in at your homes. So now you will learn, I hope, the engineering understanding of what's behind those networking. Especially there are plenty of companies in Wrocław that are dealing with the knowledge and skills we will cover during this semester, even though you are not planning to become a network administrator. Yes, so the knowledge and skills we'll cover here are not, let's say, reserved or fixed only to network administrator. Of course not. This is the baseline for the IT engineers and computer engineers. Yeah, or kind of door opener for further, let's say, career. So you can be a programmer that is also using some networking stuff, technology. You can program, for example, drivers for wireless communication. So you might be programmers, you might be the managers, you might be the owners of companies, and you need to understand where to place the computer network in the whole stuff. And especially now, we all are the users of computer networks. So it would be nice to understand a bit this tool more than just a everyday user. So more like engineers, more like the creators, more like designers. Yeah, so more details I will share for sure in the lab today.
Okay, thank you, sir.
Okay, guys, if there are no more questions, we can still discuss online or later on during the labs. So see you in 1 hour, at least parts of you, and in 3 hours with the rest of you. Thanks and bye.